Welcome to this oil palm plantation near Kampung Raja Musa in North Selangor, Malaysia. This is one of my field sites. It's a second generation oil palm plantation. As you'll see, the first generation oil palm trees have been chopped down long ago. You can see the remains of those, the stumps here and surrounding the site. And we can see the second generation oil palm trees are now well established, mature and producing palm oil. And what we can also see here are the remains of what was once a tropical peat swamp forest. We've got the exposed roots of this now long dead rainforest tree next to me here. One of the things that I'm doing here in Malaysia is looking at the decomposition of this peat soil. Accompanying deforestation, we also have the drainage of this land. This would have once been very boggy. The water would have been very close to the surface or above the surface in swampy conditions. There's very low oxygen levels in that water as well, which means decomposition doesn't occur in tropical peat swamp forest. That's why the organic material builds up and builds up over time, because it's not decomposing. And it makes the peat soil that you can see on the ground here. Now, the problem with drainage is we no longer have those conditions, those anoxic conditions that prevent the decomposition of the soil. So with drainage comes decomposition. And of course, decomposition leads to CO2 emissions. One of the projects that we're working on here in Malaysia is looking at the rates of decomposition of the soil and the rate of CO2 emissions from sites such as this. Looking at the differences between a pristine forest, which is under anoxic conditions where we don't see a huge amount of decomposition, versus these plantation sites and sites that are burned regularly, and having a look at how much CO2 is coming out of the soil. Another really interesting part of the project is we're looking at the age of the carbon that's coming out of the ground when it's decomposing. What do I mean by that? Well, we're looking at the age of the material that's decomposing. In a pristine forest, any material that's decomposing is likely to be very young. Young carbon, leaves and branches off trees that had recently grown. So we're looking at maybe 30, 40-year-old carbon. The decomposition that's happening at this site is much, much older. We're talking about the peat soil, this peat soil that was deposited over thousands and thousands of years. So the age of the emission will tell us something about the carbon that's being released. At what point in the carbon cycle was that carbon fixed, sequestered in the ground, and now we see it's being released into the atmosphere. The early signs from this particular site is that the carbon that's entering the atmosphere is very old, around 3,000 to 4,000 years old, according to the carbon dating techniques that we were using last year when I was at this site. That indicates that what we're releasing here is essentially fossil carbon. It's equivalent to fossil fuel emissions. The CO2 from the decomposition of this soil is old carbon being released into the atmosphere and contributing to greenhouse gases and global warming as well. So we'll have a look at some of the other sites as well, where we're including a pristine forest and also a site that burns. Here we are right on the edge, the northern edge of North Selangor State Forest Reserve, which is just over there across the drainage canal. At the northern edge of this site, what we can see is there's been some illegal encroachment onto the buffer zone surrounding this forest. We can see here that the forest was cleared maybe just 10 to 15 years ago, and following the forest clearance there was clearly a fire, quite a large fire, in fact multiple fires on this site. Satellite imagery suggests that there are fires every 2 to 3 years here, the last big one taking place in 2015. We can see evidence of the fire in the charring of the peat soil surrounding the camera right now, and also this charred remains of a forest tree. What's really clear here is that the forest tree, which is just here, what we can also see is the exposed roots of the tree, which suggests that the peat soil was once up to around about here. And over time, this site has lost around about a metre in elevation, a metre of soil, probably through burning, so the soil lost to the atmosphere during a catastrophic event like a fire, but also through subsidence. When this land was drained, using this canal here, the pores inside the peat that would have once have been like a sponge and storing water have been lost, and the peat begins to compact under its own weight, and also we lose elevation that way as well. One of the things that I've been doing at this site is looking at the decomposition rate of the soil. Because the peat has been drained, just like at the oil palm plantation site, the mature oil palm plantation site, the soil is exposed to oxygen and decomposes to carbon dioxide. So what we've been doing at this site is putting chambers onto the ground and watching how quickly the CO2 rises inside that chamber, which tells us the flux rate, the amount of CO2 emitted per unit of time, per unit area at this young plantation site that has experienced many fires. One of the other things that we've been doing when capturing the CO2 that's coming out of the ground is filtering the air and capturing the carbon in the CO2 and dating the carbon, looking at how old the carbon is in the CO2 that's coming out of the ground. That tells us something about the contribution to the carbon cycle that this site is having, whether the carbon is young carbon and therefore readily recycled carbon, or whether it's much older, i.e. fossilized carbon, similar to burning fossil fuels. What we find at this site, and clearly the soil here is very old because we've probably lost the younger soil that was once up to about 1 meter taller than the current elevation. The soil below our feet right now, we know from dating it using carbon dating, is around 3,000 to 4,000 years old. It was 3,000 to 4,000 years ago that this soil formed under swampy tropical rainforest conditions. Now, of course, this site is very different, and in addition to the surface being very old, also the CO2 that's being released is also very old. The carbon in the carbon dioxide that's being released is also 3,000 to 4,000 years old, showing that the destabilization of this site through deforestation, through burning, has destabilized the peat layer, and we're now accessing carbon that hasn't been at the surface for thousands and thousands of years. So this is essentially contributing to excess greenhouse gases. It's the enhanced greenhouse effect driven by land use change in tropical Southeast Asia. If we take a look at the site, we've got quite young palm trees, and in a few years' time these will be producing palm oil. So take a look around, listen to the noises. We're right on the edge of the forest here, so quite different environment to the mature palm oil plantation, one of my other sites. We can hear the sounds of the forest. We're right on the edge, and I'm also going to take another video inside the forest so you can get to experience what it's like inside the pristine forest. Hi everyone, welcome to North Selangor Peat Swamp Forest Reserve. We're right on the edge of the northern boundary of the forest reserve here, close to Sungai Besar, which is the nearby town. We're right on the edge, just the other side of these trees. Ahead of me is the road, and then there's a drainage canal, and the other side of the drainage canal is an edge of the forest that has experienced much burning over the last 10 to 15 years. Inside the forest though, it feels very different. I'm only a few meters into the forest, but the climate is different. I can feel myself sweating, the humidity of the air is very high, and the temperature is also higher as well. The canopy is keeping in the moisture, and also the trees are radiating heat. So we have a very different climate. And it's this kind of climate regulation that stops a forest like this from burning naturally. It's very unusual for there to be a forest fire in a tropical forest because of the high humidity, and both in the air, in the vegetation itself, and also on the surface. If we look down at the ground, we can see there's quite a lot of leaf litter, and just below the leaf litter is the peat soil. The water table here is very close to the surface, so it's quite swampy and boggy, and at other times of the year the water will be above the surface, and this will be a true swamp forest. And I have been here at other times of the year when it's like that, and it's actually very difficult to maneuver around inside this forest edge. What that also means is with water right near the surface, the soil is wet all year round and it's unavailable to burn. It's inflammable, very unlikely to have a fire either in the vegetation above the surface or in the peat soil below the surface. What happens in a peat swamp is that the leaf litter that falls off the tree lies on the ground, and during those swampy conditions when the water is very close to the surface, there's very little flow of water as well, so there's little oxygen in the water. And so the material that falls off the trees stays in the soil and it doesn't decompose. And that forms the soil itself over many hundreds and thousands of years. The undecomposed matter that falls off the tree forms the peat and the carbon-rich organic soil of these tropical lowland forests. That's what makes this ecosystem particularly unique, is the high organic content of its soil because of this low decomposition rate. Now, as we'll have seen at some of the other sites, the burnt site just across the road and across the drainage canal, and also at the mature palm oil plantation, we can see that because of drainage and because of deforestation and because of burning, the soil is now decomposing because the water is now far below the surface, and we have oxic conditions. The soil has access to oxygen and decomposes to carbon dioxide. One of the sets of measurements that we've been doing at these sites is looking at the amount of CO2 that's coming out of the ground, and we've been doing this at the disturbed plantation site and the burn site, and we've also been doing it at the pristine site to have a look at the difference between a pristine forest and the rates of CO2 emission, and also the rates at the degraded sites as well. One of the really interesting bits of work that we've been doing, and I mentioned it at the other sites, is looking at the age of the carbon that's coming out of the ground when we have this decomposition. The age can tell us something about the state of the degradation of the forest or of the plantation. What we would expect in pristine conditions is that the carbon that's in the CO2 from decomposition should be very young. It's coming from the leaves and the top layer of the soil that's decomposing naturally. And that, if we were to date the carbon in the CO2, and we can do that by separating the carbon from the oxygen through a filtering process, we would expect the age of the carbon to maybe be young, 20, 30 years maximum, maybe a little bit older. And that is what we find for this pristine forest site. We find very young carbon being respired, and of course at the same time we have photosynthesis with the growth of the trees, which is very typical of a forest. We have this carbon neutral situation. What's being decomposed is being sequestered at the same time by the growth of the trees. We see a very different story at the degraded plantation sites and at the burn site, where the age of the carbon that's coming out of the ground is actually many thousands of years old, because the top layer of soil has been lost through burning, and now we're accessing much older carbon, or you could even say fossilized carbon. It's not technically fossilized because it's not millions and millions of years old, but it is old carbon that is being put into the atmosphere, and that is contributing to the enhanced greenhouse effect and global warming. So take a look around this forest site. We're right on the edge, so there aren't many very tall trees. These are all maybe no taller than 20 meters. But if we were to venture even further into the forest, well, we'd start to see much taller emergent trees, very typical of a tropical lowland rainforest. Have a listen to the noises as well. Very different environment to the plantation. What we have here is a highly biodiverse environment, plenty of different species of insects and birds and mammals, and we can hear that in the soundscape of this forest. Very different to the plantation, which is a monoculture, only one species of plant, the oil palm tree, and along with that you have a whole array of impacts that affect biodiversity, meaning that we have far fewer species on these monoculture plantation sites than we do inside this lush tropical lowland peat swamp forest.